Okay, this video is how to do a phase change problem. This is a pretty long problem because it's going from all the way from ice to water vapor. So anyway, it's a 5-step problem. So the first thing that you want to do is you want to sketch your I'd like to call it the up over up over up. So you've got the up over up over up. All right, so now mark where you're starting, like we did on the other problem. So we're starting at negative 23 degrees Celsius, and we have to go to water vapor up here at 137 degrees Celsius. Now, if you can divide the graph that you sketched into 5 segments, segment number 1, segment number 2, segment number 3, segment number 4, and segment number 5. Now, you should know that ice melts at 0 degrees Celsius and it also freezes at 0 degrees Celsius. It boils at 100 degrees Celsius, and then going backwards it would condensate at 100. So anyway, that's where the temperatures fit in. Okay, so step number 1, okay, you're starting on a slanted part of the graph. Anywhere that the graph is slanted, you're going to do a Q equals MC delta T. So Q equals MC delta T. So then you plug in Q equals the mass, so it's 15.8 grams. All right, times C. Now remember that ice has a little bit different specific heat than liquid water. Ice is 2.09 joules per gram degrees Celsius times the temperature change. Well, it's 0 final minus initial. 0 minus 23 is going to equal a positive 23 degrees Celsius. So then you take 15.8 times 2.09 times 23, and that ends up equaling about 759.6 joules. You got to move the decimal 3 spots. So 1, 2, 3. Okay, so that's going to equal, if you round it off to like a couple significant digits there, like 3 significant digits, it ends up equaling 0.760 kilojoules. Okay, that's how much energy it takes to go from here to 0 degrees Celsius. Okay, number 2. Okay, number 2 is a flat spot of the graph. And so number 2, the phase change is called melting, and so you got to use the heat of fusion. And the heat of fusion to do step 2 is 6.01 kilojoules per mole. All right, so what we got to do first is take our 15.8 grams of water, which ice is still H2O, okay, and you change it to moles. So 1 mole water, okay, equals 18 grams of water. All right, and then what you're going to do is then use this 6.01. So anyway, for every 1 mole that you want to melt, you need to apply 16.01 kilojoules. If you do the math for that, it ends up being about 5.28 kilojoules. Okay, that's step 2. Now, what you should be doing is having a piece of paper out or having this worksheet out and doing this problem 3B with me, or 3A and 3B, and pausing the video and replaying if you don't understand so you can pick up how to do this. All right, step number 3. Okay, step number 3, the graph is slanted. Wherever the graph is slanted, you're going to use Q equals MC delta T. So Q equals the mass, okay, which again it's still 15.8 grams, times the specific heat of liquid water, which is 4.18 joules per gram degrees Celsius, okay, times the temperature change. And so basically the final is 100, the initial was 0, because we're just doing the temperature change for this step. So it ends up being 100 degrees Celsius. So we're going to take 15.8 times 4.18 times 100, and that ends up equaling 6,604 joules, but we need to change it to kilojoules, so we're going to move the decimal 3 spots. So that's going to equal 6.60 kilojoules. All right, now that's step 3. Okay, step 4, we have to go from here at 100, so we have to go from liquid at 100 to gas at 100 degrees Celsius. Okay, notice that that is a flat spot of the graph, so you got to use what's called the heat of vaporization. And for water, that's equal to 40.7 kilojoules for every mole. So 40.7 kilojoules per mole. Okay, so then what you're going to do is you're going to start off with the mass again, 15.8 grams of water. You have to change to moles, just like we did on step number 2. So 1 mole water equals 18 grams of water. All right, and then you're going to use the 40.7 kilojoules per mole. So 40.7 kilojoules for every 1 mole. Okay, that's called the heat of vaporization. And if you do the math with that, let's see here, what does that one equal? That one's going to equal 35.7 kilojoules. 35.7 kilojoules. All right, so that's step 4. Now we got one more step to do. That will be step 5. If you notice, step 5 is a slanted part of the graph. And so on step 5, wherever the graph is slanted, you're going to use Q equals MC delta T. All right, so Q equals the mass, once again, is 15.8 grams, times the specific heat, but we have to do the specific heat of water vapor, which is like steam, I guess. So anyway, the specific heat of that is 2.09 joules per gram degrees Celsius, times the temperature change. Well, it's going from 100 to 137, so it'd be 137 minus 100. Once again, we're only doing that step right there. So that's 37 degrees Celsius. So Q is equal to 15.8 times 2.09, let's see here, times 37. And so it ends up being about 1222 joules. So we got to change that to kilojoules. So we'll move the decimal 1, 2, 3 spots. So that's going to equal about 1.22 kilojoules. Now, what's really important when you do these problems is to remember a couple things. Okay, we're not quite done yet, but always remember these things. Wherever the graph is slanted, Q equals MC delta T. When it's flat, like on step 2, you have to use a picket fence, and you have to use the specific number. Like this would be called the heat of fusion. That's the same as melting. All right? And so on number 4, we use the heat of vaporization. Okay, remember on steps 1 and 5, the specific heat of ice and the specific heat of steam, it's not the same as liquid water. It's 2.09 when it's ice or steam. All right? Right now, once you have all 5 steps done, you just need to add them together. All right? So you're going to add together 0.760 kilojoules from step 1. For step 2, you're going to add together 5.28 kilojoules. For step 3 was 6.60 kilojoules. Step 4, 35.7 kilojoules. And step 5, which is 1.22 kilojoules. You add all that together, and I believe you should get somewhere around 49.6 kilojoules. That would be the answer. Okay, now that you've hopefully done this with me, what you need to do is try to do 3C by yourself and see if you can do it. And then once you get done, I posted the answer key on Google Classroom. Go back and check your work to see if you did it correctly. All right? Good luck to you.